You to all of our sponsors for IMOG, including Source Allies as our platinum sponsor, Lean Techniques and Grower's Edge is our silver, and Lozanotech as a bronze. Just a reminder, we do adhere to the Global AI's Code of Conduct. I don't think we'll need any crazy reminders of that, but just in case, just don't be a jerk. I think it's the best way to live your life, and also this conference. I'll post the link to the Code of Conduct as well. If you'd like to report anything anonymously, or if you'd want to report anything directly to me, feel free to reach out, and happy to help you there. And then also in the chat log, I believe you guys can see, or you all can see the Microsoft Azure free credit passes we got. So we do have 25 of those. If you haven't gotten yours yet, make sure you go up there and redeem yours. And it should be sent out to you within, I think it's like 15, 20 minutes-ish at most. And so after this talk, we will be doing the keynote AWS versus Azure versus Google AI. Just a quick preview. And then with that, I will introduce Akrem and Matt with AI. It's on your roadmap, but what's the simplest way to start?
Great, thanks, Alec. So I know we have a lot of experts that are on the call and also that will be watching these videos. I do want to be inclusive too of everyone who is interested in getting started in AI and kind of take a little bit of a step back there with what we're doing with our talk. But for the super quants and data scientists out there, there is something in here for you too. So glad we're all here because it really is an exciting time to be interested in AI and ML. We're past the buzzword stage. We are now building on top of thousands of statisticians and data scientists for the past 60 years. It's a really exciting time to be using AI and ML to innovate in your organization. And true to the title of our talk, we're going to show you a simple set of entry points to using AI and specifically machine learning. And some of these entry points actually were only introduced a few months ago, so not even a year old. For our veterans on the call, going back a few years to even get into AI and ML, you needed to know stats and linear algebra, calculus, be reading up on AI and ML research. It was a pretty big barrier. So library creators, AI community came together to build some really awesome libraries to abstract AI methods. And the major cloud platforms really started introducing these end-to-end AI services, so like AI building blocks. And you can use these pre-trained models to say, send a picture of a driver's license and get back some of the data in that, the driver's license number or fields, name and address, expiration date within that driver's license. But a lot of these models have really been kind of general purpose, so meant to be applicable by hundreds of millions of people, speech text, text to speech, face recognition, like for identity verification. And in order to build models specific to our organizations, again, you needed that data science and ML engineering skill set. However, good news is that with the ongoing trend to really democratize AI and ML, we're now seeing a new category of tools called AutoML. That's what we're going to demo for you today. As a bonus, we're also going to throw AutoML's hat in the ring for a predictive data science competition with over 2,500 ML engineers and data scientists that were competing for prize money. And the results might not be what you'd expect. For agenda today, we wanted to do quick intros, give you again that step back, kind of a brief report on the state of AI and ML, talk about some of the challenges facing organizations on their path to adoption, and then also talk about some of the recent innovations that help you solve those challenges. And again, in our opinion, AutoML is one of those important innovations that's really providing a simple way to get started with your AI journey and do it in a way that is really inclusive of all the skill sets that you need to have your predictive models really make it to production. So we'll be doing a live demo there and then finally sharing some concluding thoughts. To begin with, Akrem and I, we're not data scientists. We are software engineers. A little bit about me, back in 2002, I started a company called Source Allies, and I personally have a lot of experience building cloud data analytics architectures. Fun fact about me, my dad actually led at a university a neural networks research group, and every time he would explain it to me, I 100% did not believe it was real. Computers can make their own decisions without you telling it what to do. No way. Akrem?
Thanks, Matt. My name is Akrem Saed, and I am a senior software engineer at Source Allies, specializing in cloud technologies and building big data pipelines. I got interested in analytics by reading a book called Soccernomics. If you're familiar with Moneyball, the movie or the book, that's basically it. So yeah, it was a fun area to kind of get into.
And like Akrem said, we both work at Source Allies. It's an IT consultancy founded back in 2002. We're really driven by what our partners call an ownership mindset. At our core, we're really builders. We are data scientists, engineers, cloud architects who believe in using the simplest architecture to solve the problem at hand. And we work with our partners anywhere from a pair to full delivery teams. So if you'd like to talk with either Akrem or I afterwards, we'd be happy to talk more. To get kind of a sense of what roles everybody is in, could I get, like, with a hand raise feature, a showing of people who are using AI today, or plan on piloting AI yet this year? Akrem, how many are showing up here? What percentage? Okay. All right. So that's good. We'll kind of proceed. How about anybody who's on a data science team today? Or managing your organization's ML platform. So, like, are you in some sort of ML ops type role or ML engineering? Okay.
Not, but I see a wish. Alex says he wish he was on a data science team, I think.
Sweet. Okay. So then this will be good, what we're going to talk about, because we're going to do this kind of quick state of AI, and our whole talk is about how to make that wish come true. Quick report out on AI and ML. AI, you might have seen this graph before, but AI is the umbrella term for automating intellectual tasks performed by humans. ML is the subset of that. That really is taking inspiration from how the human brain works. So just like you and I can read and listen and act on data, ML is able to extract information from both structured and unstructured data and act on that data. So examples of ML would be like you get a call from your credit card company about fraud. There's likely ML behind the scenes there. And then finally, a subset of that is called deep learning. And that's where you get into the multi-layered neural networks that can perform tasks like speech and image recognition. So here, it's really anything that you can, images, video, text, audio, anything that you can distill down into numbers. You can pass through these multi-layered networks and get predictions out the other end. So anybody out there working with PyTorch, TensorFlow knows what this is. And then we've all used it, things like Google Translate or any kind of photo management app that's like pooling together all your friends based on facial recognition. But when we talk specifically about ML, which is what we're focusing in on today for the demo, arguably 80% of enterprise ML use cases really come from either tabular or time series data. And that's a good thing because enterprises have lots of tabular data, lots of spreadsheets and data on servers. That's the kind of thing that we have access to today. So really with that data, you can hit a lot of these use cases that you see on the screen. They really range from a wide variety of verticals: sales, marketing, finance, accounting. In sales, you can do things like predict the lifetime value of a customer. Finance and accounting, you can do credit risk scoring, and in operations, you can take like sensor data with equipment and start to do predictive maintenance of that equipment. So like I said at the beginning, AI, it's a 60-year-old field. And one of the interesting things that we're noticing is the speed at which AI and ML is being adopted by organizations. So go back 5 years ago, Forbes was saying a quarter of organizations have incorporated AI into their product and services offering. Then fast forward to today, looking within the next 2 years, Gartner is predicting 3/4 of companies are going to shift from piloting to actually operationalizing AI. So it's really massive progress. It's in part due to the democratization of AI, the increasing accessibility of AI tooling that we're going to show you, and ever-growing AI communities like Hugging Face, where it's not just the leading research companies. Many companies now are companies and individuals are contributing to the speed of progress with AI. So AI, ML, it's not a buzzword anymore. It's not the future anymore. It really is essential to innovation today. We've covered kind of some of the common business cases. Next couple slides, I want to look at some of the more leading edge AI developments, just so you can see how fast we're moving. I mentioned research organizations. A couple of the leading ones are DeepMind and OpenAI. And I'm sure everybody here has heard of GPT-3. It's a very large language prediction model that was trained on corpuses of text, entire data sets like all of Wikipedia. So you provide some context, and there's a continuation of that text. So the content that is generated, really, it's almost indistinguishable from what would be written by a human. And interestingly, guess what both of these leading AI research organizations have focused on next? Software development, us, our jobs. So DeepMind has developed AlphaCode, designed to compete in competitive programming competitions. And then there's also a descendant of OpenAI's GPT-3, and that was actually trained on many millions of GitHub repositories. So that's the auto-completion, the AI that's powering GitHub's Copilot. So how many people here have worked with Copilot before, have played around with it? All right, Akrem, as software engineers, how nervous should we be about this AI pair programming kind of stuff?
Very nervous, but hopefully code reviews is going to slow down the bots, hopefully.
Yeah, for now, our jobs could get easier thanks to AI assistance, really. But according to a lot of the research that's done into security vulnerabilities found in it, our responsibilities will definitely be expanded to keeping an eye on the AI, because all of this, again, is being it's being pulled from not copies, but it's being learned by code that we are writing as humans as well. Another really important factor that is speeding things up is training costs. Training costs are declining at what appears to be twice the rate of Moore's law. It definitely plays a role in the democratization trend, where AI can be affordable by not just the very, very largest companies. And finally, by the end of the decade, AI is predicted to increase the output of knowledge workers. So that's software engineers, accountants, bookkeepers, lawyers, paralegals by 140%. So my goal before passing it off to Akrem was just to show you the really rapid rate of advancement of AI and really how it's been fueled by cloud and hardware acceleration. And hopefully I've done that. Akrem?
Thanks, Matt. I'm going to share my screen. So just like Matt was talking, there is a huge amount of innovation happening in the space, and a lot of companies that want to adopt AI. We're talking about 3/4 of the organizations want to be moving from piloting to actually using it in production workloads. But along with that comes the challenge of scaling up the people part. As you can see in the chart in front of you, the number of machine learning experts is about 2 million people, which is small if you compare it to the number of developers and business users out there. And LinkedIn is saying that the demand for those experts is increasing by 74% annually. So what that translates to is an arms race for hiring those experts, and that might put ML out of reach for a lot of organizations because they can't afford to. The one thing that we're hoping that the recent innovations are going to do is change the dynamics a little bit. So instead of competing for 23 million experts, developers and business users are going to have the tools at their hand to kind of dabble in this space. So they don't necessarily need to have deep knowledge about statistics and calculus and linear algebra to contribute in this space. Instead, they can use the tools that are coming out in the past year or so that makes it a lot easier to dabble in this space. So we're talking about going from 2 million players, let's call them, in this space to potentially 123 million, which is 50-fold. And that's definitely possible today. If we take a step back and think about all the different options or levers available to organizations to kind of scale up or jump into the ML space, you can think of 3 major ones. On the left-hand side, you can improve your ML team productivity by using off-the-shelf cloud technologies that speed up your productivity. You can try to expand your team by hiring more people, but like we talked about, the demand is pretty high. LinkedIn is saying that the demand is twice more than any other emerging field. And the third step is to take advantage of the democratization that is happening in the space with tools that makes it more approachable and accessible to business users and developers. So when we talk about improving the productivity, there are a bunch of building block tools that you can use today in the cloud. If we look at the domain like natural language processing, there's a lot available on the 3 major cloud providers, right? So you got their AWS, Azure, and GCP. We're talking about speech to text, text to speech, chat bots, translations, document analysis. And we even saw in one of the first presentations today how chatbots is really easy to jump into that because it has a very easy interface to kind of go through. And the advantage of this using it in the cloud, one, you don't need to build a data center. You just have a cloud capacity that you can jump into. And you're going to go with the pay as you go kind of model. So there isn't that much upfront cost. And then you're going to take advantage of all years of experience and refinement that went into these products. So you don't have to start from scratch. And then when we talk about the democratization, it will be beneficial to us to look at what the process looks today if you want to start an ML project in an organization. And you can break it into 4 phases. So on the left-hand side, the first phase is to gather business requirements. And then you want to do data preparation and feature engineering. and then model development, training, and tuning, and then finally they deploy the model and monitor it. And there is kind of a feedback cycle that goes back, because as you use your ML model in production after 6 months, 7 months, whatever it may be, you will learn more about the performance of your model. So you might have to do refinements, either to add more features or to improve the features that we have. Now, in today's world, if you look at the second line there, it tells you the different people or roles involved in each phase. And you will notice that data scientists and ML experts are heavily involved in phases 2, 3, and 4. So that becomes a resource constraint, especially when you think about phase 3, which is very, very time consuming. Because what the experts are trying to do is try different combinations of feature engineering, hyperparameter tuning, ML algorithms to kind of see what kind of improvements they can do on their predictions, just to get that additional 3%, 5% improvement in accuracy of the model. And this is very, very time consuming. So today there are tools that can aid with phase 3, where that iteration over different combinations can be automated. So the ML experts and data scientists can have some time back from doing that menial work. And also there are tools that enable developers and business users to contribute in steps 2 and 3 by using very easy to use interfaces. And we're going to talk about that, and we're going to demo one of those tools today. But one thing for sure, even when we use that tools for business users in phases 2 and 3, you definitely don't want to deploy this immediately to production. There has to be some sort of a gate or guardrails between phases 3 and 4. That's where a lot of the ML expertise that data scientists have will be beneficial, because what they can do is look at the model that was generated and make sure that it adheres to the ethics rules that they have. It doesn't have bias. It's actually sound, the accuracy of the predictions, and the business value that it adds, right? Making sure that it's up to snuff, so to speak. And then you want to deploy that. So definitely you don't want to just build an ML tool and then deploy it to production. You want to have some guardrails. And that's one of the biggest advantages to one of these tools that we're going to demo today, is that it allows you to do that. These kind of automation and improvements that I've been speaking of is possible thanks to something called guided model development, or AUTOML for short. And these are a set of tools that are available on the 3 major cloud providers. We're going to focus on AUTOPILOT. If you look at the AWS column, the first item there, SageMaker AUTOPILOT, and there's a sister tool next to it called Canvas. Canvas is something that a business user can use, and AUTOPILOT is something that an ML expert or a data scientist can use to actually get more details. If we're looking for an analogy as to what kind of democratization is happening, we can think of all the websites that exist today in the world. A lot of these were built by small business owners, photographers, bloggers, who used no-code tools like Squarespace or something like that to build a very professional-looking website, and they were able to deploy it to production. So that led to this explosion of the number of websites available out there. And today, with these tools that we're talking about, it achieves the same thing. So you have a very simple UI tool that an analyst can use on the left-hand side right here. It's very simple UI. They can upload their data through it, and then ask AutoML to kind of iterate on different types of models and combinations of hyperparameter tuning and feature engineering to produce the best model. Then it will present that best model in an easy to understand way that the analyst can understand how accurate it is it giving the business value that we expect, but also it gives us the ability to pop the hood, so to speak, and look underneath at the details of how this model was built. And that's where data scientists on the right-hand side can use that kind of detailed view to make judgments on the soundness, ethics, bias, or lack of bias in the model that was generated. So that's where the gate or guardrails are going to become very important. Another way we could use these kind of tools is in project prioritization. Generally, when you want to build an ML tool, you're going to weigh all the different ideas, all the different projects that you have in mind that you think is going to be beneficial to ML, and you're going to sort them out by how ready the data is. That's the first criteria you see. And what is the business impact? Does it have a high business impact or a low business impact? And the third one is the one that kind of had been a challenge a little bit, which is figuring out, is the problem solvable with ML? Is ML the right hammer for this nail? And a lot of times this was a judgment call from data scientists based on their experience, and most times they probably are right. However, now you could just shove the data into a tool like Canvas, let it spin for a couple of hours and see what kind of results you get to kind of help you in that assessment. If it's able to get you, let's say, 80% of the way to a very good prediction, then maybe this is something to invest on and build on. Or maybe if it performs very poorly, you can decide, you know what, this is not something worth the investment right now. There are other things that seem more applicable to ML, so we're going to use with that. So now we're going to talk about the demo piece of this. So we're going to be demoing SageMaker Canvas and SageMaker Autopilot. So I'm going to exit the slide deck right here. And double check to get rid of this nice reminder from Teams. So the tool we're going to talk about is Canvas. And you can access it through AWS console. The data science competition that Matt was mentioning early on is this Prudential Life Insurance Assessment. This is a competition that was posted in Kaggle. If you're not familiar with Kaggle, that's a data science competition platform where competition exists there and data scientists can compete for a prize money. The prize money for this one was $30,000. And you can see there was about 2,600 teams who participated in this. I'm going to increase the font just a little bit, so it's a bit more readable. Now, there's a lot of details in this post, and you can look it up. I think the critical pieces for us is if I go to the data tab, this competition provides us with two sets of data, a train and a test. The train is what we're going to use to build the ML model, and the tests are just like the name implies. We're gonna release our ML model onto the test data. It will generate predictions, and then we will submit it to Kaggle to tell us how well we did. So for the train, we already know what we need to predict and the actual value, but for the test, we don't. Now, this data set is they have a nice explanation about what columns exist and what they mean. The most important thing for us is this is applications for life insurance, and each insured person provided information like their health status, their age, their height, their employment, and all that necessary information that an insurance company takes and decides on a rating of risk of how risky is it to insure this person. This is an important piece of information to know in life insurance because that determines the premium and the liabilities that the insurance company is going to take on. So that rating is in a column called response, and it's a number that ranges from 1 to 9. So the higher the number, that means this person is more risky. So an 8 is more risky than a 5, for example. So we already downloaded this set of data, and then we went to Canvas. When you go to Canvas in AWS, this is the screen that you're going to land on. On the left-hand side, you will see 2 important navigation points. You got the models, that's where your model is going to live, and data sets, that's where you're going to upload data that you want to use in the application. So I already uploaded the data. As you can see here, the first item and the second item, Prudential test and Prudential train. I uploaded the data, and it does a bunch of analysis for me about how big the data is and that kind of stuff. What I can do is then select the train set and click on Create Model, and I'll start building my ML model. So I'm going to give this one Global AI Demo. Create. The first step that it's going to do is going to crack open the file, give me the list of columns right here in the lower half of the screen. It tells me the list of columns that exist in it, what types of the column is, and some interesting statistics. If I click on this button that is called Grid View, it will provide also statistics about the values inside of these columns. As you can see, the WT column, which is short for weight, you can see the distribution of it, response, and so on. And if I click on one of these columns, on the right-hand side, we will see some additional statistics. This is very important to kind of understand the quality of the data that we're dealing with and whether it has a very good distribution across the different values for us to generate predictions. So this screen is probably the one that you're going to spend a lot of time on, trying to understand the data, the distribution of it, the quality of it, and what you want to use for prediction as input and what is your prediction output. The first decision I need to make is to select a column to predict. So right here, as we remember from Kaggle, the column is a response. It gives me a nice value distribution graph and also gives me a recommendation. It says, well, based on the data, what you want to do is a 3+ category prediction, right? And this is also a point where a data scientist is helpful. The first time I ran this, I just went with Canvas recommendation, which is 3+ category prediction, and it generated a prediction. And then I showed it to my data scientist, John, who was very kind to kind of help us with this. And he said, well, maybe next time you want to try a numeric prediction. So if I go to change type, it will give me this nice option, which is a numeric model type. And the reason he said that was there is an order to the data. 8 is a higher risk than 5. So doing a numeric prediction will help us capture that priority or that kind of importance of the value. So I use a numeric prediction, and then right here on the right side, I'm going to have a button called Standard Build. So I can click on that, and Canvas is going to launch an experiment. They call it an experiment. I'm not going to click on the button right now because it takes about 2 hours to finish. So I'm not going to have you bear with that. But generally what it's going to do is spin up experimentation to kind of find the best ML model. And we're going to learn more about how it did that in a video that I'm going to play in a little bit. But generally, you just click standard build, and then you come back after a couple of hours, and a model is going to be ready for you. I already built that, which is this one. Now when I click on it, it lands me immediately into the Analyze page, and it tells me the model often predicts a value within plus or minus 1.8 of the actual value for a response. So this is how good the accuracy of the model is. And it's written in a very plain English to kind of understand without using too much jargon. And also, on the left-hand side right here, it gives me the list of columns that were used in prediction, sorted in descending order based on their impact. So right here, product info had the biggest impact, employment information was the second, BMI was the third. That what impacted the prediction. And this is part of the explainability report that you're going to hear a lot when it comes to ML models. You want to be able to explain how the model was able to produce its prediction, and this is one part of it. If I go to the scoring screen, it also gives me a nice chart, and it has an explanation. If I click on advanced metrics, this is a screen where data scientists are going to find more useful because it tells us about all the different predictions made and how close they were to the actual value. And it has some statistics like mean absolute error and R-squared that are useful when training an ML model. But that's all good. It's a high-level overview. A data scientist will look at this and would say, you know what, I need more detail. And luckily, Canvas provides that. We just need to click on the share button right here, and we can include a message if we want. So I can say, John, I need your expertise on this model for life insurance. And then I click on create Studio Link, it gives me this link and I can email it to John. John then will be able to open it and it will basically pop the hood and show him the details of the model and how it was built. Luckily, one of our data scientists, John Chapman, was kind enough to do that and analyze this model for us. And also, he was even kinder and recorded a video of that assessment. So I'm going to play it for you. It's about 4.5 minutes, and it will basically walk us through the steps that a data scientist or an ML expert is going to go through to kind of analyze what Canvas produced.
See the artifacts that were generated by.
Everybody able to hear? All right.
See the artifacts that were generated by the AUTOPILOT job run. And what AUTOPILOT does is it experiments with different types of models and different parameters. And it's going to build 250 different models and evaluate how well each one performs. And they're ordered by our objective, which is accuracy. And right off the bat, I can get a sense of how our best model is performing. So we can see it's a 0.597 in terms of accuracy. If I want to dig deeper, it's really nice that we have 2 different notebooks that AUTOPILOT generates. The one is a data exploration notebook, and it basically just gives you some exploratory graphs, summary statistics, and that sort of thing, just so you can get a general feel for what your data looks like. I can see right away that we had a lot of applicants with a really high risk level. We had a decent amount with a low risk level, but not many in the middle. So it's kind of a heavy tailed distribution, which can give me some useful information if we're working with a regression problem and using a mean squared error objective that could cause issues. So it's just good to see this. It tells us about duplicates, and then we've got a correlation matrix for the predictors, anomalous rows. So it has a metric for determining if a row looks unusual, missing values. So we have a few columns here that are almost entirely missing, and then the number of unique values, and lastly, our basic descriptive statistics. So we've got things like the average, the median, the min, and the max for each column. And so this is all some good, just basic things that I would want for probably any analysis, just to get a feel for the data. The other notebook is the candidate generation notebook, and that gives me more insight into where these 250 models came from. And one of the nice things is there's a lot of explanation. You can read through it. If you're newer to data science, you can Google terms and use this as a learning tool. So what AUTOPILOT does is it experiments with different ways of transforming your data. Before you train a model, you have to do things like encoding all of your data numerically through one-hot encoding, imputing missing values. So you might replace the missing values with the mean or a missing value indicator, scaling columns so that they're on a similar scale and all. There's all sorts of different transformations you can try out. And so AUTOPILOT is going to try a bunch of those, and it's going to fit a basic model after that transformation, and it's going to pick the 10 best models, and each one is paired up with a type of model. And so another thing that AUTOPILOT does is experiment with different types of models. So here we have XGBoost, which is a very powerful tree gradient boosting model. Here we have a linear learner, which has more linear models like logistic regression. I think down here we also have a multi-layer perceptron. That's more of a neural network type model. We've got all these different models, but that still just gives us 10. That doesn't give us 250. So where does the 250 come from? So once it has these 10 promising models, it's going to experiment with different hyperparameters. So for each type of model, there are still parameters that can be tweaked. So for example, with XGBoost, you can modify the hyperparameters, and that's going to affect how XGBoost picks up on the patterns in the data. And so that's the next phase that AUTOPILOT goes through. It tells you the hyperparameters that it's actually tweaking, and then also the range that it's searching over for each hyperparameter. So for example, numRound is a hyperparameter, and here's the scale for it. This to me is one of the best features of AUTOPILOT from a data science perspective, because there's so many models, there's so many hyperparameters. It's hard to know exactly which ones are most important and what range to search over for each type of model. So it's nice to have these reasonable ranges set for you already. From my perspective, this is all really nice because this is sort of tedious stuff, hyperparameter tuning and featureization that I don't necessarily enjoy doing manually. It's nice to have that automated. But I'm still able to come in here and kind of review things and see, does this look right? Do I see any issues, anything that stands out? You can also tweak things. For example, the objectives that you can use through the console are kind of limited. So if I want to, use something less common, I guess, that's supported by these packages, I can come into this notebook and tweak those and rerun this autopilot job, and it'll create 250 new models according to that new objective. So this is really great for reviewing, for critiquing, for tweaking things and rerunning.
Awesome. And that was the analysis that a data scientist can perform thanks to a tool like this with SageMaker. So we're going to switch back to my slide deck. So we did a demo of Canvas, which is a tool that a business user or a developer can use. And then we also talked about Autopilot. That's the tool that John evaluated, which is basically the backbone of Canvas. And then on the other cloud providers, there are similar tools. We have on GCP, there is AutoML tables. It has a very similar UI, similar kind of results and models. The key difference is probably that it doesn't give you that under the hood view to kind of evaluate how the models were built. So that's one con to using the GCP. And before I go next, I'm gonna hand it over to Matt.
Thanks, Akrem. Okay, so at the beginning, we talked about we're going to put AutoML head-to-head with the 2,500 data scientists. Who believes that AutoML 1 had the model with the higher accuracy? Anybody? Any takers? Because that's what we're going to show you next. All right. Nobody fell for that one. It was not AutoML. The humans won. You can see the accuracy scores up at the top there. About like 62% accuracy for AutoML, about 68% accuracy for all of the crowdsourced effort that went into the Kaggle competition. So it's not bad for uploading a spreadsheet, pressing a button, and waiting a few hours. But what's exciting to me isn't the score, because actually, when you look at the difference between like first place in Kaggle and 500th place, it's like 0.001% of a percentage point. It's more for me about the demonstration of the democratization of AI. You saw the tooling, you saw how inclusive that can be to all of the disciplines that are really needed to bring a model to production. The win is really this really tight feedback loop. So it's just like everything we're trying to accomplish with Agile. You're trying to shorten the feedback loop, and we are able to get feedback really fast on these models. We also are solving a problem, and it's kind of depicted in the lower right-hand part of the slide. This kind of chicken or egg problem, this conundrum where how do you know if you should build a team to mobilize around solving a problem if you don't know yet if it has good ML applicability. So you can run it through this and get some quick feedback to know it is the initial pass, initial 250 passes, are those looking good before we really invest more time into it, both from taking valuable data scientist time, and then also just from the fact that building the model is still just 30% of the effort. Running, maintaining, retraining. There's a ton of effort in keeping that model alive and healthy. So what Akrem and I are recommending, we're not saying push the button, publish straight to production. We're definitely using more of the self-driving car analogy, which is all about you're going to want to keep your hands on the wheel. Where data scientists, ML engineers, ML ops, model governance even are going to be continue to be very important for really a variety of reasons, not the least of which is model ethics, like Akrem talked about earlier, and safety. But the point being, isn't amazing just how far you can get from a really rapid discovery perspective to get fully explainable ML predictions in just a few hours without any heavy ML lifting? Okay, so we did talk about like how you get started, a little bit touching on where to get started. What we recommend is essentially starting small. The data is data that you have. You have it sitting around. It's just a matter of committing to get more value from the data that you already have. The next recommendation that we have is to take an existing business process rather than a brand new, super cool, innovative thing. Take something existing that you have and ask the question, what if we could make the decisions inside of this business process, X% better? What would be the impact to our business as a result? And then finally, this is like kind of the fist bump. Do your data scientists a solid. Run some AutoML for them. You heard John talking about how he doesn't like doing a lot of this tedious manual work. There are more interesting parts of the problem solving that a data scientist would rather spend their time on. And a lot of these recommendations are really supported by industry experts as well. You have Andrew Ng, he's one of the leading AI researchers. His perspective is that we think that AI requires like tons and tons of data, but often it doesn't. He talks about like a pizza shop. Often it just requires a very modest amount of information to do a lot with AI. We also, the idea of starting small is supported by articles you find around, like this one in InfoWorld that says, start small, start simple before beginning your bigger AI journey. And then finally, the idea that a win is a win. There is no such thing as a small win, so get those wins and get started. And that's what this is all about. In summary, AutoML is a great way to get started. It's a great way to jumpstart ML exploration, especially of tabular and time series data. The democratization that we're talking about, it's real. You can get now business and data marketing analysts involved in generating ML predictions without ML expertise, and you don't have to wait for a full ML team to get started. All really great things. And finally, main takeaways is that if ML is on your roadmap, AutoML, it's really a great way to prioritize your projects. So especially from a ML applicability or the data readiness, it's a way to figure out what should we tackle, because it's going to take time and resources. What's a really good candidate that will set us up for success, and just get started from day one without waiting. And if ML isn't on your roadmap yet, then hopefully this shows that maybe it's not as complicated as you might have thought. So that's all that we had for today. We hope that you found this useful so that you can start using some of these new tools to take advantage of them in your AI and ML journey. And Akrem and I are happy to open it up to any questions you might have.
Thank you, guys. I'm going to go ahead and stop the recording in case anybody wants to ask a question off the record.